Okay friends, let's go ahead and practice our multiplying by powers of 10 and 100. We're going to start with 16 2/10 times 10. And I'm sure you know by now that we're going to rewrite our number 16 2/10. You guys do this along with me. When I'm writing, you're writing. Then we're going to move our decimal point over one place value position to the right. So our product is 162. Next, we're going to take 16 2/10 times 100. I'm going to rewrite my number, 16 2/10, add a 0 as a placeholder, move my decimal point over 2 spots. So my product for this one is 1,620. Now we're going to divide by 10, which means our number will get smaller. 16 2/10 divided by 10 means our decimal point is going to move one place value position to the left. So our quotient, or our answer, is going to be 1 62 hundredths. Last one, we're going to divide 16 2/10 by 100. Okay, now our decimal point needs to move over 2 spots because I have 2 zeros in 100. 1, 2. Now my number is getting really small. My quotient is going to be 162 thousandths. Next, we're going to solve our measurement problem. Now, in order to convert centimeters to millimeters, we need to know that there are 10 millimeters in 1 centimeter. So in order to solve this, we're going to take our 99 centimeters and we're going to multiply it by 10, and that will give us 990 millimeters. A millimeter is really small. A millimeter is about the thickness of the white part of your pinky fingernail. It's really, really small. I would say that's about a millimeter probably, the space in between those two lines. Okay, next we're going to take 58 centimeters and we're going to convert that to meters. Now there are 100 centimeters in 1 meter. And for this, we're converting a smaller unit of measurement to a larger one. So fly to horse, divide, of course. I'm going to divide 58 centimeters by 100 centimeters in each meter. And in order to divide this number, I need to rewrite it with the decimal point included. With whole numbers, the decimal point is understood to be there after the ones place. You can include it or not include it, but when it comes time to divide something and move the decimal point, of course you're going to want to include the decimal point. Now, since I'm dividing by 100 and I have 2 zeros, I need to move my decimal point over 2 spots. So that's why I put that 0 there as a placeholder. So my quotient is 58 hundredths of a meter, a little more than half a meter. Okay, now to find our equivalent fraction for 1/3, we need to remember that we can read a fraction 1 out of every group of 3. Understanding that a fraction can be read 1 out of every group of 3 helps us understand that when we find an equivalent fraction, we'll increase our groups of 3. Okay, so we can take our 1 whole, which I've represented here with this rectangle, and divide it into 3 equal pieces. We'll shade in one of those pieces, and that will represent our 1/3. Now, to find an equivalent fraction to 1/3, all I have to do is take this whole, and without changing the size of the whole, that's important with equivalent fractions, we don't change the size of our whole, just create additional groups of 3. And the easiest way to do that is just take each third and cut it in half like this. Now, instead of 3 equal pieces, I have 6 equal pieces, and 2 of them are shaded. So 2/6 is equivalent to 1/3. Okay, now we're going to subtract these decimal amounts, and the easiest way to do this is to think of them as being amounts of money, because you know how to subtract money. You stack up the numbers by place value. We have our hundredths in a stack. We have our tenths in a stack. We have our decimal points in a stack, and we have our ones in a stack. And then we just go ahead and subtract them. And I don't see any regrouping that needs to happen here. 7 minus 5 is 2. 6 minus 4 is 2. And 5 minus 3 is 2. So that leaves us with 2 and 22 hundredths. Okay, now for rounding, I'm going to get you started and let you finish this one on your own. 567 and 87 hundredths. You're going to round it to the nearest tenth. And then you're going to round the same number to the nearest whole number using the ones place. And then one last rounding assignment, you're going to round this number to the nearest tens place. So remember, the best way to do this is if you're rounding to the nearest tenth, locate the digit in the tenth place and then use its next door neighbor to help you round. Okay? Then we're going to locate, let's see, the digit in the ones place and then use its next door neighbor to help you round. Find the digit in the tens place and use its next door neighbor to help you round. So you guys go ahead and do that one on your own. All right, guys, last problem for our bell ringer. Now these fraction line plots are tricky because before you can put them on a line plot, you have to find a common denominator for all of these. So we're going to do that part first. Okay, I'm going to leave this one for last. So we need to find a common denominator for 3/4, 4/5, and 3/9. So I know that 3/9 is the same as 1/3. So that means that I need to find my least common multiple. For those 3 denominators. Least common multiple for 4, 5, and 3. So let's go ahead and skip count. 3, 6, 9, 12, 15. I usually, when I'm trying to find the least common multiple, I'll just skip count like the first 5 multiples and then see what I can find. 4, 8, 12, 16, 20, and then 5, 10, 15, 20, 25. Okay, so I've done my first 5 multiples for my denominators, and now I need to find the smallest multiple that's on all 3 of these lists. Now, I would say 12, but I don't see a 12 on here. Let's see. And I see 15 on these 2 lists, but I don't see a 15 on this list. So that tells me I'm going to have to keep going. Let's see, 18, 21. Okay, so now we're getting to the point where we've come up with all these multiples and still haven't found the least common multiple. So in a case like this, the easiest thing to do is to take your 3 denominators and just multiply them together and use that as your common denominator. So we're going to multiply 4 times 5 times 3. 4 times 5 is 20, and 20 times 3 gives us 60. So our common denominator for these is going to be 60. That means that we're taking our whole and dividing it, instead of dividing it into 4 equal pieces, we're dividing it into 60 equal pieces now. And when we do that, let's see. So when we do that, we're multiplying our denominator times 15 and our numerator times 15. 4 times 15 equals 60, and 3 times 15 equals 45. So 45 out of 60 is equivalent to 3/4. Now for this one, instead of dividing our whole into 5 equal pieces, now we're going to divide it into 60 equal pieces. And in order to do that, we're going to multiply our denominator and our numerator times 12. 5 times 12 is 60, and 4 times 12 is 48. So 48 is equivalent, or 48 out of 60 is equivalent to 4/5. Now, let's see. For 3/9, or 1/3, I'm going to multiply both of these times 20, and that will give me 20 out of 60. So these are the values I need to put on my line plot now. This one was a really hard one, guys. I'm going to have to put 45 out of 60, 48 out of 60, 20 out of 60, and 9/3 on my line plot. Now to figure out what to put on my line plot for 9/3, we have to remember that this fraction bar means the same thing as a division symbol. And I know that 9 divided by 3 equals 3. So my values on my line plot are going to have to go from 0 to 1 to 2 to 3. And I'll have 1x on the 3, and then I'll have these other fractions marked. Okay, so I think the way I'm going to divide up my space in between 0 and 1 is, let's see, 20 out of 60, 40 out of 60, and then one whole is going to be 60 out of 60. So 20 out of 60 goes here. 48 out of 60 is going to go approximately right there. And then 45 out of 60 will go approximately right there. That's kind of the best I can do. Sorry, guys. That one was really hard.